Welcome dear students. Rolling and rotation are the most complex topics in physics for IIT JEE, and every year many good questions come up from these concepts. So today I'll be explaining you the basic methodology to attempt the rotation and rolling problems without any error. Also I will tell you the most common point in which the students get confused and the chances of mistakes are very high in those concepts. So let us take two examples and solve it. Suppose this is a question, and here you can see there are two identical masses of they are uniform cylinders and each of mass m, on which two light threads are wound. Find the tension in each thread in the process of motion. The friction in the axle of the upper cylinder is 0. So the biggest problem students face in this question is that they are not able to calculate acceleration of this lower cylinder in the ground frame, because actually it is a complex motion. You see, this cylinder is rotating something like this, this cylinder is rotating something like this, and because of their combined rotations it is actually moving down. So this downward movement is essentially the result of this rotation and this rotation. So how can we relate them? Let us see. I will give you two methods to relate the motions of these two cylinders. First is the superposition principle. Superposition principle. In this, what we do, we take only one rotation at a time and find the downward motion of the cylinder and then add the downward component due to the rotation. So in this, what is happening? Let us say in a very small interval of time dt, this cylinder has rotated by what? Let us say it has rotated by d theta 1, and in the same time interval dt, this cylinder has rotated by small angle d theta 2. Okay, and the center of the cylinder in the same dt time has moved downwards, let us say by dx. Okay, so what we will do, we will take the contribution in the downward movement first only due to d theta 1, then only due to d theta 2, then simply we will add both and we will get the resultant dx. How we'll do it? Let us see. Here I am drawing the assembly. Let us see like this. This is the string and it is somewhere here. Okay, suppose I lock this lower cylinder with the string. I paste a sellotape so that no unwinding of the string can occur and it cannot rotate. And now if I rotate this cylinder by a very small angle, let us say d theta 1, what do we feel? How down this cylinder will go? Let us say it will come somewhere here. Okay, sellotape is still there. So what this distance will be? Obviously if r is the radius, then this will be r d theta 1. Simple. Okay, so the contribution of d theta 1 is r d theta 1 downward. Now what we do, we remove this sellotape from here and put it over here, so that now we lock this system from rotation. Now we will let only this one rotate. How much? Angle d theta 2. Now we will rotate it how much? D theta 2. So, and this is locked. So simply it will be a rolling downward motion and it will come further down where? Somewhere here. So what this distance will be? This distance will be simply r d theta 2. R d theta 2, isn't it? And that means what total distance it has traveled? If it is dx, as we told here, dx, then dx is what? Simply sum of r d theta 1 plus r d theta 2. Very simple. That means we can easily say dx is nothing but r d theta 1 plus d theta 2. And in what time all this activity is occurring? In time dt. So simply divide it by dt. You get what? This dt, and this dt. So this gives you what? Velocity, downward velocity is r times sum of angular velocities of the cylinders. If you differentiate it once more, you get acceleration. Acceleration downwards it what? R times angular acceleration alpha 1 plus angular acceleration alpha 2. So see how simple equation you got. For such a complex motion, you got a simple equation. Alpha 1 is the angular acceleration of this one and alpha 2 is the angular acceleration of lower one. Okay. So this is one method which we call superposition principle. Other method that is also very easy. See what we do in that. Again I am drawing the same assembly. This is the assembly and something like this it is happening. Now let us fix a point P here on the string. This point is attached with the string and is moving down with the string. So if you see the downward acceleration of, let us call the downward acceleration AP. What do you think? AP has nothing to do with the lower part. It only depends on the acceleration of the angular acceleration of the upper part. So very easily we can say AP is R alpha 1. AP is R alpha 1 and let me draw its direction below it. So R alpha 1 downwards. AP is this one. Okay. Now if you see, now you forget the upper part and you just focus on the lower part. This is something like this and its angular acceleration is alpha 2 as we assume. This is point P. So what, and this is, let us say, mass m. What do you feel acceleration of m with respect to P? Acceleration of m with respect to P will be what? It will be simple. Let us write here. Acceleration of m with respect to P will be what? It is pure rolling downward, that is R alpha 2. R alpha 2 again in downward direction. Now you got this, you got this. So simply write the relative acceleration equation which says what? Relative acceleration of any two bodies is something like this. Okay. So what is AM from here? AM is nothing but sum of AP which is R alpha 1 downwards plus sum of MP which is again R alpha 2 downwards. This is what? This is R alpha 1 and this is R alpha 2. So their addition will be simple what? It will be vector addition and it will be downward with magnitude R alpha 1 plus R alpha 2. So again you got the same thing which you got in this one. So essentially both the methods are correct and you can use whichever you liked. So now we have got A is equal to R alpha 1 plus alpha 2. So now the problem has become very easy. Now simply we need to apply the dynamic equations. Let us see how. There are two strings. One string is behind this one, so that is not visible. So let us call acceleration, the tension in the string, in this both string is T. So sum total of the forces is 2T. Okay. So if you see only the upper part, what is happening over here, and we have already got in the previous equation what? If its acceleration is A downward, it is sum of R times sum of alpha 1 plus alpha 2. This you need to remember as we have already derived it. Okay. Now you see from the upper circle what is happening. This is the upper circle. It is somewhere here and 2T is pulling it downward and its angular acceleration is what? Alpha 1. So what you can write? Tau is equal to I alpha. What will be tau? Tau is 2T R equal to, let us say moment of inertia is I alpha 1. Okay, for the upper cylinder. Now same if you do for the lower cylinder, if you see in lower cylinder what is happening, this is lower cylinder, 2T is acting upwards, mg is acting downwards, and as it is accelerated body, so you need to apply pseudo force, but whatever pseudo force we will apply, it will be in upward direction. It will not affect the rotational motion. So again, regarding the rotation motion, you can see what 2tr is the tau, 2tr is what I times its angular acceleration is what alpha 2. It's something alpha 2. So 2tr is equal to I alpha 2. So from this equation and this equation, it is pretty clear that alpha 1 is alpha 2, both are same, and let us call this combined acceleration as alpha only, so as to not get confused in 1 and 2. So see how simple it has become. That means we can say A is what? A is nothing but 2r alpha. Okay. Now we will use it in the later part of the equation. Now let us see force balancing on this part. In this part, what we can say, we can simply write, this is the assembly is something like this. This is 2t, this is mg, and it is moving downward with acceleration a. So what we can write, we can easily say mg minus 2t is equal to m times a. A is what? 2r alpha. So let us write directly 2r alpha. This is the first equation. And if you see the rotation, I mean, already we have drawn the rotation thing. So if you see the rotation angle, then rotational equation, then you get what? 2tr tau is equal to I alpha. Let us focus on the upper cylinder. 2tr is equal to I alpha 1. So here what we can say, 2tr is equal to I alpha. So I is what? M times, for the cylinder it is mr square by 2 times alpha. So from here you get what? You get T is equal to what? T is equal to mr alpha by 4, or simply you can write 2t is equal to mr alpha by 2. mr alpha by 2. This is the second equation. So you simply put the 2 in 1. So you get what? mg is nothing but 2t plus 2t is what? mr alpha by 2. mr alpha by 2 plus 2 mr alpha, isn't it? This means what? It is 5 by 2 times mr alpha. Okay. Now r alpha, from here what you know, r alpha is nothing but a by 2. So if you put it a by 2, it becomes what? It is 5 by 2 m times a by 2. That means mg is what? Mg is equal to 5 ma by 4. Okay. So this gives you what? This gives you that a is equal to 4g by 5. A is equal to 4g by 5. Now you simply put it in this equation, so you will get all the results. So like here you see 2t is what? mr alpha by 2. So t is equal to mr alpha by 4. So just write it. T is equal to mr alpha by 4. mr alpha by 4. R alpha is what? See here. R alpha is a by 2. So is equal to m upon 4. R alpha is equal to a by 2. And a is what? 4g5. 4g upon 5. So it becomes m upon 4 times 1 upon 2 times 2g by 5. Okay. M upon 4 times 2g by 5. So if you solve it, you get simply mg upon 10. So this is the tension and this is the final answer we got. Okay. Similarly, the second problem, if we look, this is also pretty same. but arrangement is a bit different. In this, a block is of A is having mass m and a pulley is having mass capital M. The moment of inertia of the pulley is axis, about the axis is I. So if this is the axis, then moment of inertia about this is I. Its mass is capital M, its mass is small m, and the radii are given as r and 2r. Okay. So again, the maximum problem which students face is in finding the acceleration of this mass. What will be the acceleration in ground frame for this? So same methodology, same two methods which we used in the previous, we are going to see how they are applied here. This is the initial situation. Okay, at some point of time, this is the ceiling and it is hanging something like this. Now within a very short span of time dt, what will happen? Let us say that it rotates something like this with angle what? D theta 1. It is rotating with angle d theta in this case in a very short span dt. So and it is actually rolling motion. So what we will do? We will take it rolling as a sum of rotation, or we should call it spin plus translation, and we will superimpose the results. So first we will take only spin part. That means I am fixing its center C, this at this, let us call this center, and C is fixed over here, and only the pulley has been given a spin by angle d theta. So what will happen to this mass? It will definitely come down by how much? If the outer radius is 2r, then it will come down by how much? 2r d theta, isn't it? Because this is 2r. So it will come down by 2r d theta. And what will happen to this string? Actually, because of the rotation, and since the pulley is not allowed to translate, this string will become a bit loose, something like this it will become. Okay, so situation is something like this. Here this is the ceiling, and what is the length of this loose string? Its length will be, if initial length, if this length is L, then length of this string will be L plus r d theta. R d theta is the extra string which got unwound because of the spin. Okay, and as we see, this distance is what? This distance is nothing but 2r d theta. 2r d theta. So spin part is now covered. This plus, I mean, if you get a simple spin is there on its own axis, then you get here. Now spin is done. Now we will take care of the translation. So what do you think? This whole system now needs to be pulled down so that this string becomes tight again. So how down should we pull? Definitely extra length of the string, which is r d theta. So we need to pull it down r d theta, something like this. Okay, now the string has become tight again. So what do you think? What is this distance? This is simply r d theta. And since pulley has translated down r d theta, here in this part pure translation is there, no spin is allowed. So that means from initial to final, this is also what? R d theta. So how much distance the block moved in total? Total distance is this one. Okay, this is what? 2r d theta, this plus r d theta this. So total distance the block moved is nothing but 3r d theta, and the distance the pulley moved is r d theta. So this all is happening in a very small time. So if we call dx block is equal to what? 3r d theta, and pulley if we call p, then dx downward pulley is what? R d theta. Dx means the distance which the object has moved down. Now you simply differentiate with respect to time. So what we get? dxb upon dt is 3r omega. You differentiate it once more, you get acceleration B is what? Acceleration B is 3r alpha, where alpha is the angular acceleration of this pulley. Okay, so A block is 3r alpha. And what about acceleration of pulley? From here you get simply differentiate and you get acceleration of pulley is what? R alpha. See how just by visualization we got both the values. Another way is also simple. I mean, as in the last case we discussed, let us if you want to follow that way, then also we can do. Let us say some point P is there fixed on the string. Okay, so now you forget this lower block. What if the string remains tight and this is rotating with angular acceleration alpha? What is the acceleration of P? Acceleration of P will be simply 2r, this distance 2r times alpha. 2r alpha downwards. This is the acceleration of P. Okay. Now, if you mark this point at center C, so what is the acceleration of C here? I mean, if you see here, then acceleration of C is simply r theta. Acceleration of C is r alpha, sorry, because the inner radius is r alpha. It is down. Now, if you just imagine, then you can very easily say, in this case, we can visualize it as actually what AP is. Actually, AP is the acceleration of P with respect to C. P with respect to C. Because you see, if you hold it and let it roll down, then the acceleration of P with respect to C is 2r alpha. And acceleration of center of mass C itself is r alpha. So P with respect to C is having this value and acceleration of center is having this value. Now again the same equation which we used last time, APC is what? APC is what? It is AP minus AC. That means AP is what? AP is APC plus AC. So simply APC is what? 2r alpha downwards. AC is what? R alpha downwards. So their sum will be what? 3r alpha downwards. This is the acceleration of P in the ground frame. And as the string is the same, string is tight between P and B. So A block will be same as AP and it will be 3r alpha downwards. Okay. AB is 3r alpha downward and AC we have already seen what? R alpha downward. So see, by this method also we got the same acceleration. So you can choose whichever method you like. So since I've got this basic thing, now let's come to the dynamics, the forces involved in this one. So here we have got, let us say its acceleration is AB, it is 3r alpha, and acceleration of this is AP downwards, where AP is what? R alpha. Okay. Now this is the ceiling. See, and these are actually two strings. So let tension in one be T1. They are back to back, so they are not visible. So let us call the tension here 2T1. T1 is the tension in the upper string, and here the tension be T. Okay. So let us write the fourth equation for this one. In this, what is happening? T is upward and mg is downward, and downward acceleration is this. So simply write it. First equation is what? Mg minus T is equal to, and its mass is m, and moment of inertia is I, we have already told. So mg minus T is equal to what? MAB. MAB is what? 3r alpha. 3r alpha. Okay. Let us call this equation 1. Now you see, for this part, if you write the equation, it is, let us draw a figure like this. Figure is something like this. Downward force is what? T. Upper force is what? 2T1. Another downward force, gravity, mg, and it is moving downward with acceleration ap is equal to r alpha, as we already calculated in the last page, isn't it? See, AC, I mean the center of the pulley is moving with acceleration r alpha. I should write it actually AC instead of here. A center is equal to r alpha. Okay, this is the acceleration of center of mass. So write the equation for this. You get what? T plus mg minus 2T1 equals to what? Capital M times acceleration is what? R alpha. R alpha. This is the second equation. Okay. Third equation will involve the rotational equation of this. So rotation, what you can say, what is the total torque? Torque in this direction is what? T times 2r, T times 2r plus 2T1 times r. 2T1 times, this T1 should be drawn here because it is here. Okay. So this is actually 2T1 and this is wrong. Let us just erase it out so that you don't get confused. So here this is 2T1 and not that. Okay. So you can see for the rotation, the clockwise is T times 2r plus 2T1 times r equal to what? I times alpha. This is the third equation. Now by solving this, you can, what you have to find, you have to essentially find AB. AB is the acceleration of the downward. So from these equations you can very easily say, here you see, if we just add, subtract 3 from T plus mg minus 2T, and if you let T plus T1 will be what? T plus T1 we can write from the equation as something like this. So 3 can be written as, if you just divide it by 2, then you get what? You can write very easily T plus T1 is equal to I alpha upon 2r. Okay. Let us call it this equation 3a. Now from 1 and 2 you just eliminate this t. So what you get from 1 and 2, you get 2T1 equal to m plus mg, capital M plus small m times g, minus r alpha times capital M plus 3m. This is what you get from 1 and 2. And 1 can be written as T is equal to what? T is equal to mg minus 3m r alpha. Mg minus 3m r alpha. Okay. So putting this in 3, T1 value got, T value got. Now you put both these values in this equation 3a. So what you get? You get mg minus 3m r alpha. You get mg minus 3m r alpha plus m plus mg by 2 minus r alpha times r alpha upon 2 times capital M plus 3m. It is simple mathematics. Now physics part is over. So you need to be very careful that you don't commit silly mistakes in such calculations. Okay. So rest is all done. So I alpha upon 2r. If you reorganize it a bit, then you get m plus 3mg, m plus 3m g by 2 minus r alpha times 3m plus m plus 3m by 2 is equal to what? I alpha upon 2r. Okay. So now you see r alpha you can write out. Let us see, let us call for simplicity AB, this acceleration we call in a simple term A, so as to not confuse A, B and all. So A is what? R alpha upon 3. So replace this R alpha by A by 3. So what you get? M plus 3m G by 2 minus R alpha, we write A by 3. A by 3 is what? It is actually, if you solve, it becomes m plus 9m by 2. 9m by 2 is equal to what? Here also I upon 2r. In place of alpha, you just write A upon 3r. A upon 3r. Okay. So it becomes, if you just now you A you have got here, A you have got here, bring both sides and solve them. So very easily you will get what? You get m plus 3m by 2 times G is equal to what? A by 3 times m plus 9m by 2, m plus 9m by 2 plus I upon 2r square, I upon 2r square. So if you further solve it, I mean, you see 2 gets cancelled, 2 gets cancelled, and A you get what? A is simply m plus 3 times m plus 3m times G upon m plus 9m plus I upon r square. This is the final expression for the acceleration of the lower block. So you see how we can simplify the rolling motion in a simple process just by visualizing superposition method. So if you have any doubts, any queries, any confusion in any part of my explanation, then please feel free to ask in the comments, and if you have any suggestions, any doubts to improve myself, please give the suggestion also. Thank you.